Okay, so let's go to so because we say so it is in equilibrium. So we determine the reactions in A, B, and C. So equilibrium means summation F equal to 0 and summation M equal to 0. Okay, you write these two first. And then we draw the free body diagram. Now, and the structure, the structure looks like this. And then we have a point, and then we have here. So, and then we have points A. I'm sorry, I should use blue here. Sorry, and I should blue here. We have points A, B, and C. Point A, B, and C, and D somewhere here. Now, we have flange field at A and B. So what do we have? What kind of supports we have? What kind of supports do we have at A and B? Let's look at the flange field. Let's look at flange field. So can this field go up and down? Can it go up and down? No, because there's a rail, right? So can it go left or right? No, because there is a flange. So can we go along the rail? Yes. So we have two forces. We have reaction force here. We have reaction force here in this direction, and we have reaction force in this direction. Okay. And also we have we after talk about the free forces, we talk about the free moments, and we have the wheel can rotate in this direction. Can it rotate in this direction? No, because this flange that it cannot rotate in this direction. So we have a support moments there. Sorry. Okay, we have a support moment there. Wait a minute. Eh? Sorry. And it can, because it is sorry. Usually because it is loose, that it can rotate. It can rotate a bit here. Sorry. So it can rotate here. It can rotate a bit here. So we have only two forces, and because it can, of course, it can rotate in this direction. Wait a minute. It can rotate in this direction, and it can rotate in this direction, and can it rotate in this direction? The wheel. It is a bit loose here, so we think, let's say we think we can rotate a bit here. And we have, of course, this wheel can move in this direction. So the only two directions that we cannot move are in this direction and this direction. So we have two forces here. And for unflanged wheel, that it can move left and right. So we have only one force here. It's okay. Now, let's put them into a free body diagram. So we have for flange wheel at A and B. Let's do them first. So we have flange wheel and unflange wheel. So we have we put them into the free body diagram. Now for flange wheels A and B, we have let's say we have x y z is x y y and z. So we have a y and a z. And we have by and bz. And for unflanched wheel, the unflanched wheel here is it is quite the unflanched wheel. For the unflanched wheel, the unflanched wheel is in this direction. Okay, so of course these flange wheels are in this direction. These two flange wheels are in this direction, but this flange wheel is in this direction. So this is not in this direction. This direction. So the reaction from point C is going from in this direction. C. So any forces to add in this figure. We have 1, 2, 3, 4, 5 forces and anything else? 有没有其他？还是已经画完？ Or we have mark all the forces there. So we still have remember that in this problem we have this 80 kilogram man and that 20 kilogram ladder. So the combined weight, there is a combined weight. So combined is okay, so we have a combined weight to put on the free body diagram W, and it goes through points D, and you can add dimension by yourselves, and of course in a free body diagram you need dimensions, but because I don't have time, so how many unknowns do we have here? So we have 6 forces here. How many unknowns do we have? How many unknowns do we have? 1, 2, 3, 4, 5, 6. How many? How many? 1, 2, 3, 4, 5, 6. W is known. This is 100 kilogram weight or 100 kilogram force. And but the all 5 others are unknown. So we have 5 unknowns. And we have 5 unknowns. And how many equations do we have in 3D problem? How many equations do we have a 3D equilibrium problem? We have 6. Okay. So something is wrong here. Something is wrong here. Because for 5 unknowns that as you learn from mathematics, that 5 unknowns should have 5 equations. So that is you can get these 5 unknowns, but we now have 6 equations. The problem is in this lambda, it can move left to right. So all the forces are in y or z direction, and no forces are in x direction, and the lambda can move left or right. So we do not need to satisfy. We do not need to meet this one. So actually, we have only 5 equations. It's okay. We have only 5 unknowns and we have 5 equations, and so we don't need to satisfy this one. And afterwards, that you have 5 equations that and summation fy equal to 0, summation fc equal to 0, and then you take a point ma, and then we have take point A, and then we have MA equals to 0. Okay, so and that's and then from here you can get the results, and this is on page 210 of the book. If you need this, I can put it on iLearning. Right, and okay. And so this is all we have on page on chapter 4. And before I end today's lecture, so I have some points to talk about. And the first one about the problem 4.83 we talked in the last hour. That this one. The first thing is I draw these 2 pegs are in the wrong position, and the one at E should be the peg at E should be there, and the peg at D should be there. So I draw them in the wrong position. Okay. So E is there and D is there. So we have the 2 forces here. This is the first thing. It's okay. So peg E is here, peg D is there. So we have E going here and D going there. The second problem is why is this force equal to 45 degrees? And now I think it is okay to say that alpha is equal to 45 degrees, right? It is okay to say alpha is equal to 45 degrees. So this is the first thing that the first thing is, I'm sorry, let me go to, let me open a new page. So for this triangle that I think all of us are okay with this is 45 degrees, right? This is the first thing. The second thing is we have a isosceles triangle here. 等腰三角形 right? We have isosceles triangle here, and then we have from a isosceles triangle we can draw a line here CH, and CH is perpendicular to DE. It's okay. So because this one is 45 degrees, this one is 9 degrees, so and this one is 45 degrees. Is that is the logic here? So the first thing is we have 45 degrees here, and the second thing is that we have I should write step 2A. 2A. And we have isosceles triangle DCE, right? This is isosceles triangle DCE. And from this isosceles triangle, we have we put a line here CH, and CH is perpendicular to DE. And so we have 45 degrees here, 9 degrees here, so this one is 45 degrees. A bit complex, but I hope you accept this.